All right, so continuing on with linear transformations, we're looking at we're going to be finding the matrix A that does the transformation, so from Rn to Rm. So we're going to be finding that m by n matrix. All right, so how we're going to do that is we're going to look to see what it does to the columns of I and in this fashion. So we've already been kind of playing with this, but our matrix A, our first column is going to be what the transformation does to E1. And then the nth column will be what the transformation does to E2, En. So let's look at this one here. So I'm being told the transformation goes R2 to R2. E1 goes into this, E2 goes into this. So that means that my A matrix will be, so let's just write out what it's going to be, what the transformation does to E1 and what the transformation does to E2 as a second column. No commas in between here, right? Because these are two different columns of the matrix. And our columns of the matrix are these two columns that are given. All right, so if I've got to make a transformation going from R3 to R3, and I'm being told what the E's transform into, my matrix A will be, I'm just gonna, you don't have to write these steps out, but I wanna make sure you see what I'm doing. So E2, transformation of E3. So these are three separate columns of the matrix A, no commas between them, and you are completely okay to go right to this answer here. I just want to make sure you see what I'm doing using the notation given. All right, so here I'm moving into this next one where I'm telling you that when I take the matrix A times this column vector x1, x2, this is what I get. So what I'm asking you is, what is this matrix A? And you know that it's got to be a 3 by 2 matrix, right? So it's going to be the matrix 3, -2, 1, 4, 0, 1 that gets multiplied by x1, x2 to get 3x1 minus 2x2. x1 plus 4x2 and then x2. So you would just need to write down the answer A. I just want to make sure that you see where I'm getting that from or how I'm thinking about it. So this is the matrix A. All right, so more new notation facts. So writing the column vector, we're going to write it sideways as x1, x2. So instead of writing this, we like this better. So we're going to write it like this. So this here, I'm telling you, here I've got the A is the transformation, and this is what the transformation does. It takes the column vector x1, x2, I'm just writing it sideways, and transforms it. So make sure you're looking for the commas, because the commas are going to tell you the different rows of the matrix. So here's the comma right here, right? Okay, so 3x1 plus x2 is the first row, and x1 plus 5x2 is the second row. Okay, so I want to identify what the domain is and what the codomain is. So because I'm looking at this matrix, oh, first it said find the matrix A. I'm sorry, let's find the matrix A. So the matrix A will be 3, 1, 1, 5, right? And the domain will be R2, and the codomain will be R2. So remember, if A is a 2 by 2 matrix, this is the size of the domain, and this is the size of the codomain. All right, just happens to be a 2 by 2. These next ones will be different, so we'll be able to play with it a little bit. So here I have this transformation takes x1, x2 to this. So let's just be really careful on looking for the commas. So there's the first row, there's the second row, the third row, and the fourth row. So again, I'm going to rewrite it so we can see. So what I'm saying is my transformation, my t of x, is going to x1 plus 4x2, 0, x1 minus 3x2, and then x sub 1. Okay, so I'm trying to find out what is the matrix A, so that if I multiplied it times x1, x2, I get this. So hopefully you can see this is going to be 1, 4, 0, 0, 1, negative 3, 1, 0. So this is the matrix A. So again, I'm just writing a bunch out. You could just go straight to the answer and say this. But I just want to make sure you see how I'm getting it. You can take as many steps as you'd like. All right, so to take and find out what happens to this domain vector, applying the transformation means take this matrix A and multiply it by 3, 2. And that's 3, 2 is in the domain, right? This is a domain vector, column vector, and what it takes it to by matrix multiplication is 11, 0, negative 3, and 3. So this is in the range, not only in the codomain, but in the range. Range means something it's in the codomain that's hit, right? So looking at the size of the matrix A is a 4 by 2 matrix, right? So these are the size of the domain vectors. So the domain vectors come from R2, and these are the size of the codomain vectors. So the codomain vectors are R4, and we can see that, right? Because a range is a codomain vector that's hit, so that's an R4, and this was our domain vector, and it was an R2. All right, let's finish off this page. So here I have this transformation. So again, look for the commas. So there's our first row and there's our second row. So I think, well, let me just write it out so make sure you can see. This is the same thing as saying x1 plus x2, 4x1 plus 5x2. So I'm trying to find out what is the matrix A that if I multiply it times the column vector x1, x2, I get to this. So hopefully you can see A is this matrix right here. All right, so to find the x, this is saying find the x's in the domain that go to the vector 3, 8. So that's talking an augmented matrix. So I want to find out the x's if I solve this augmented matrix. Then putting in my calculator. Oh no, I guess I didn't put in my calculator. I just did this one by hand. So I got 1, 0, 7, 0, 1, negative 4. So I've got that my x sub 1 is 7 and my x sub 2 is negative 4. So my solution for x is 7, negative 4. So let's state the domain and the codomain. So this, it's a 2 by 2 matrix, right? A is a 2 by 2 matrix, but let's just make sure the domain is this R2 and the codomain is this R2, just to make sure you're getting it straight in case they were different numbers.